All right, let's talk about a trap that, pretty much every single one of us developers falls into at some point. Premature optimization. We're going to dive right in because honestly, learning to sidestep this one thing can save you so many hours and make your code a whole lot better.
We've all been there, right? You spend your entire day head down just tweaking and refactoring this one little piece of code. You make it more complex, way harder for anyone else on your team to understand, but hey, it's for speed. Then you run the benchmarks, and the entire app is maybe 3% faster. Was that really, truly worth your day? That's the question we're going to get to the bottom of today.
So, where does this temptation even come from? Well, it's that little voice in our head that tells us to optimize our code before we even know if it's slow. It feels so productive, so clever, but as we're about to see, this habit can be the source of some pretty big problems in software engineering.
So let's put a name to it. What are we really talking about? Well, the official definition is right here. Premature optimization is when we start changing our code to make it faster without any data, without any proof. We're just guessing what's slow. And in the process, we make our code way more complicated and harder to maintain, all for a speed boost that might not even be real.
And listen, this is not some new idea I just came up with. The absolute legend, computer scientist Donald Knuth, warned us about this way back in 1974. His quote has become iconic in our field for a reason. It has stood the test of time because it hits on a fundamental truth. You've got to make your code correct and clear first, then you can worry about speed.
But this isn't just, a philosophical debate or some old-school programming advice. No, there is cold, hard math that proves why most of these little tweaks we make have such a tiny, tiny impact on the overall application. It all boils down to something called Amdahl's law.
Think of your program's total runtime like this donut chart. Your code doesn't spend its time evenly across the board. Just look at this example. 60% of the time is stuck waiting on a database query. Another 30% is just parsing data. That's 90% of the total time in just two places. We call these hotspots. So if you spend all day optimizing that tiny 5% slice for logging, it's barely going to move the needle.
And this whole donut chart idea, it's actually formalized by a principle called Amdahl's law. It's basically a mathematical formula that acts as a serious reality check. It tells you the absolute best case scenario, the maximum speedup you could possibly get by optimizing just one part of your system.
And here's the kicker, the part that really drives it home. According to Amdahl's law, if you take a piece of code that only accounts for, say, 5% of your app's total runtime, and you magically make it infinitely fast, poof, it takes zero time, the maximum total speedup you will ever get for the whole application is just a little over 5%. All that work for a gain you'd barely even notice.
Okay, so if guessing is the problem, what's the solution? Well, it's actually pretty simple. It's a professional workflow that completely replaces guesswork with hard evidence. It's about being a detective, not a fortune teller.
And this is it. This is the workflow, a super simple 5-step process for optimizing the smart way. Step 1, and this is the big one, write code that is correct and clear first. Then, and only then, you move to step 2. You measure with a tool called a profiler to find out what's actually slow. Step 3, you identify that hotspot. And only after you've done all that, you go to step 4 and optimize that one specific part. Finally, you measure again to prove your change actually worked.
Okay, enough theory. Let's make this really concrete because code tells the real story. We're going to look at a classic Python example, finding the most common words in a big chunk of text. This shows the difference between a clean approach and a prematurely optimized one perfectly.
So on the left, you've got this simple, clean solution using Python's built-in counter. Anybody can look at that and know exactly what it's doing. Now look at the right. This is the micro-optimized version. It's doing manual counting using a more complex data structure. It looks smarter, right? But it's way harder to read, a nightmare to maintain, and probably has more bugs. The real question is all that complexity actually making the important part any faster?
And here's the smoking gun. A profiler report tells us the truth. Would you look at that? Over 97% of the total time is spent just breaking up the text, tokenizing it, and counting the words. The actual step of selecting the top words, which is the only thing our clever code was trying to optimize, takes less than 3% of the total time. Optimizing it was a complete and total waste of effort.
And this really gets to a much bigger point. It kind of reframes what our goal is as software engineers. Our job isn't just to write the fastest code imaginable.
It's about building effective, understandable, maintainable solutions that actually solve real problems for people.
So let's wrap this up with a handy checklist you can take with you. Before you even think about optimizing, just ask yourself these questions. First, is my code correct and clear? Second, have I actually measured it with a profiler? Third, am I targeting a proven bottleneck? Fourth, is the tiny speedup I might get really worth making the code this much more complicated? And maybe most importantly, could a better algorithm give me a way bigger win than any of these tiny tweaks?
So I'll leave you with this final thought, which really gets to the very heart of what we do as engineers. Is our job to just shave milliseconds off of a function in a vacuum, or is it to build robust, elegant solutions to the right problems? Because sometimes knowing when not to optimize, that's just as valuable as knowing how.